Hello students, today let us discuss the topic pumps. So pumps are nothing but they are hydraulic machines which convert mechanical energy into hydraulic energy. So they are hydraulic machines which convert mechanical energy into hydraulic energy. So pumps are mainly used for two purposes. So two main purposes of pumps. So they are mainly used for two purposes. The first one is to lift the liquid from available low elevation to required high level. So usually at buildings or at home, we see that there is a sump, okay, which contains water which must be sent to the elevation, that is the high level tank which is present on the terrace usually. So from this level, from the low level to high level, we are sending water with the help of pumps. So this is the main purpose, the first main purpose, to lift liquid. So common example is elevating the water from low level, available low elevation, to the required high level. So this is the first main purpose. The second purpose of pump is to circulate the liquid in a closed circuit under pressure, overcoming the resistance of the circuit. It is to circulate the liquid in a closed circuit. Closed circuit under pressure, overcoming the resistance of the circuit. So the liquid is circulated in a closed circuit where there is resistance for the circulation of the liquid. So pumps are driven by some prime movers which can be IC engines, steam engines or electric motor. So we should know that pumps are not run on their own. So they have to be driven by some prime movers. By some prime movers, and those prime movers are, maybe they can be IC engines, or it can be steam engine, or an electric motor. So without prime mover, pumps cannot work. So here you can see a single acting piston pump which can be taken as the example. So here this is called as a piston pump because it consists of a piston, okay, and there is a cylinder. You can see there is a piston and cylinder arrangement, okay. There are two valves, one is suction valve, the other is the delivery valve, okay, and two pipes are also there, suction pipe and delivery pipe, okay, and there is a cylinder pin, okay, which is held inside the piston, and this piston is driven by a crankshaft, okay. So this crankshaft consists of a crank pin and a connecting rod is also there, okay. So when we study the different types of pumps, we will understand the working better. So pumps are classified as two types. See, the pumps are classified as reciprocating pumps and centrifugal pumps. Okay. The first type, that is the reciprocating pumps. So reciprocating pumps. So here this type of pumps consists of a piston or a plunger which is reciprocating inside a cylinder. So it consists of piston or a plunger. It can be a piston or a plunger which reciprocates inside a cylinder. Okay. So this piston performs suction and delivery strokes. The piston which is present inside the cylinder performs suction and delivery strokes. So reciprocating pump. So this is a single acting piston pump. Okay, this is a type of reciprocating pump. So here you can see there is a piston and a cylinder. So a piston is contained inside a cylinder. So this piston will perform the suction and delivery strokes. Okay, delivery strokes. So these type of pistons, that is the reciprocating pistons, pumps, that is they deliver the same quantity of liquid against any head. So these pumps deliver same quantity of liquid against any head. Okay. So a reciprocating pump works at low speed. So they work at low speed. Now, piston pump. Okay. So piston pump may be a single acting or double acting piston pump. So here in the figure you can see name is mentioned as single acting piston pump. So it may be single acting or double acting piston pump. So as the piston moves outward, that is towards the right in the figure, partial vacuum will be created inside the cylinder. So what happens when the piston moves outward? It is in this direction, okay, towards the right in the figure. So then what happens here? Vacuum will be created inside this cylinder. So as the piston moves outwards, then partial vacuum is created inside the cylinder. The atmospheric pressure which is acting on the surface of the liquid pushes the liquid towards the suction pipe in the cylinder. So you can see here there is liquid. So because of the vacuum produced inside the cylinder, there will be pressure acting here on the surface of the liquid. So what happens when partial vacuum is created in the cylinder? Then the suction pipe will start pulling the liquid inside the cylinder and the suction valve will get opened. So the atmospheric pressure acting on the surface of the liquid pushes the liquid through the suction pipe into cylinder. So when the piston moves backward, that is when it moves in this direction inside, then what happens? That is the inward stroke. Then the piston will compress the liquid in the cylinder. So here during the suction stroke, what happened? The liquid is present inside the, comes inside the cylinder. Then what happens? When the piston moves inward, then the liquid will be compressed inside the cylinder and the pressure of the liquid will increase. This will close the suction valve and it will open the delivery valve. Then the liquid will be pushed through the delivery pipe and it will flow towards the top. So when the piston moves backward, the piston will compress the liquid in the cylinder and pressure so this will close the suction valve and open the delivery valve. So then liquid will flow through the delivery pipe and is pushed upward. Okay. Now, so piston pump is a type of reciprocating pump. Now we will discuss about the centrifugal pumps. So classified according to various criteria. So these centrifugal pumps are classified according to various criteria. According to drive used, they are classified as electric motor driven, then diesel engine driven. Then according to head developed, they are classified as low head pump. It is up to 15 meter. Then medium head pump from 15 to 50 meter. Then high head pump is beyond 50 meters. Then according to the rate of discharge, that is the capacity, they are classified as low discharge pumps, medium discharge pumps, and high discharge pumps. Then according to the type of impeller used. Impeller used. So they are classified as open impeller, then semi open impeller, and closed impeller. According to the number of suction openings provided, according to the number of suction openings provided, they are classified as single suction pumps, double suction pumps. Then according to the type of casing used, according to type of casing used, they are classified as volute casing, whirlpool casing, then turbine pump. Then according to number of stages, they are classified as single stage pumps, and these pumps are suitable for heads up to 50 meter. 50 meter. Then multi-stage pumps, and they are for heads beyond 50 meter. Okay. Then according to method of the method of priming, they are classified as manually primed pumps and self primed, that is automated pumps. Then according to application, they are classified as stationary pumps, then portable pumps, that is trolley mounted, then submersible pumps, and deep well pumps. Okay. Now, according to the direction of flow over the impeller, according to the direction of flow over the impeller, they are classified as radial flow, then axial flow, and mixed flow. The last classification is according to the range of specific feed. Range, according to the range of specific speed. So they are classified as radial flow, 10 to 50, then mixed flow 30 to 170, and axial flow 100 to 460. Okay, so this is the classification of the centrifugal pumps. Now we will see the mechanical efficiency of a pump. Mechanical efficiency of pumps. So mechanical efficiency is defined as the ratio of energy supplied to the water by the impeller per kg to the energy supplied to the pump shaft per kg. So it is the ratio of energy supplied to water by impeller per kg to the energy supplied to the pump shaft per kg. So the mechanical efficiency will account for the mechanical frictional losses such as coupling, then windage bearings of the pump. So the mechanical efficiency thus accounts for mechanical frictional losses such as coupling, then windage bearings of the pump. So how do we write the mechanical efficiency? It is denoted by eta, and we write it as rho, that is the density, into Q theoretical, into G, that is the gravity, into H, this is virtual, divided by the brake power. So where is the density of fluid, that is kg per meter cube, then Q theoretical is theoretical flow rate of discharge. So this is denoted in meter cube per second, and BP is the brake power supplied to pump shaft. It is in kilowatt because it is power. Okay, then now we will see what are the applications of these pumps. Applications. So pumps are used for water supply. Okay, they are used for water filter or purifier units. Okay, and they are used for pumping liquid from a bore well or borehole. Okay, to remove water from a construction site, pond, or mine shaft. To remove water from a construction site, pond, mine, shaft, etc. Then they are used for firefighting systems. Pumps are used for water blast, then hydro mining, that is mining water from the lower levels, and jet cutting also. So high speed water is used for jet cutting purpose. Then they are used in gardens, then fish pools, then ponds and fountains. So these are all the applications of the pumps in water supply. So here they have given different levels. Okay, so L1 is the main starting, then the L2 is the overhead stop. So here, okay, so this is a overhead tank and underground tank. So from the underground water, how we are going to raise the water to the overhead tank is shown here. Okay, so from L1 main start, okay, to L2 the water reaches from different stops. Okay, so L3 is the stop. Okay, this is the lowest level of water. Then we can see L4, it is the start, that is the beginning of the water level. Okay, L5 is the emergency starting. L6 is the dry run. Okay, here this is the dry run, and L7 is the hold, that is the topmost level of water. So this is how we use pumps in our daily life. So I hope you have understood the topic. Thank you.